So now let us start with the first question. This was asked in JEE Mains 2024. Let the foci of a hyperbola coincide with the foci of ellipse. So the ellipse has been given to us with some center, and the eccentricity of the hyperbola h be the reciprocal of the eccentricity of the ellipse. So overall they have given us all the details about the hyperbola. From the ellipse equation we can find out its foci, and the foci of hyperbola and foci of ellipse are same since they are coinciding. That means we would know what the foci is, and they have told us about the eccentricity relation as well. So from there we can find out the eccentricity as well of hyperbola. From all these three values we would have our equation of hyperbola ready, and after that what have they asked us? If the length of the transverse axis of the hyperbola is alpha and the length of conjugate axis is beta, then the value of 3 alpha square plus 2 beta square is equal to. So basically we need to find out what are the values of our a and b. So let us look at the question. So the ellipse has been provided to us, which is x minus 1 square by 100 plus y minus 1 whole square by 75. I hope you all remember while studying ellipse, I had told you that whenever there is a standard form with a center provided to you, try to convert it in such a format in which we know that the center of that ellipse is 0. So let us say that there is a capital X which is equal to x minus 1, and there is a capital Y which is equal to y minus 1. So from here we know now that x square by 100 plus y square by 75 is equal to 1. So for this ellipse, we can define what our focus is. One of the focus would be AE comma 0, and the other focus would be minus AE comma 0. So first let us find out things about this ellipse. For this ellipse we know that A is equal to 10, B is equal to root 75, and E square would be equal to 1 minus B square by A square. So E would be equal to half. So we know what our E is, we know what our A and B are. So now what would be the focus? Focus would become A into E. Sorry for that. So our focus would become AE comma 0. So A into E, which is 5 comma 0, and focus 2 would become minus 5 comma 0. Now this is the focuses for this ellipse. However, in the question we were given this ellipse, so we have to convert it in this format. That means capital X is equal to 5 comma minus 5, and capital Y is equal to 0 comma 0 from both the ellipses. That means x minus 1 is equal to 5, so x would be equal to 6, and in the other case x minus 1 is equal to minus 5, so x would be equal to minus 4, and y for both the cases would be similar, so y minus 1 would be equal to 0 and y is equal to 1. So that means we've got the focuses. Now the foci are f1 is equal to 6 comma 1 and f2 is minus 4 comma 1. So I hope you must have understood till now. We had assumed this ellipse into a standard ellipse with center is equals to 0. For that we found out the focus, what our focus is, and from there we converted the values of x and y into the coordinates of small x and small y, which was required for us. Now for our hyperbola we know what our foci are, and for the eccentricity, now of course even if I assume x to be capital X to be x minus 1 and capital Y to be y minus 1, the eccentricity of both these hyperbolas will be same. So for eccentricity of the hyperbola, they have said us that the eccentricity is reciprocal of that of ellipse. So here it was 1 by 2, so now here ellipse eccentricity would become 2. So now for our hyperbola we know a lot of information. We know the foci, we know the eccentricity. So let us draw the diagram to find out things more easily. Let's say this is our hyperbola. Of course now there is some centers, the center is not 0 comma 0. We do not know what the center is. So one of our focus is 6 comma 1 and the other focus is minus 4 comma 1, and we know eccentricity is equal to 2. Now what has been asked to us in the question? If the length of the transverse axis is alpha, That means this length here, this is alpha. So we need to find out what alpha is. Now again, let us take into consideration that this is one of our standard hyperbolas where this can be written as AE comma 0 and this can be written as minus AE comma 0. So from here, at least we can make out that AE would be equal to 6, and from here we can say that A is equal to 3. Sorry for that. So now we know that the length of transverse axis is alpha. We know that this distance from both the focus, this distance is twice AE for any standard formula. That means we can write this as alpha E. If you remember, we had studied this, that the distance between two foci is always written as length of transverse axis into eccentricity. That means the distance between these two foci is alpha into E. So now we can use distance formula to find out the distance between these 2 points. So the distance between F1 and F2, this is equal to root under minus 4 minus 6 would make it 10, 10 square becomes 100, plus 1 minus 1 becomes 0. So this is 10. That means this is equal to alpha into E, where we know the value of E is 2, so alpha becomes 5. So we found out the first value that was asked to us in the question, length of transverse axis, which is 5. And the length of its conjugate axis is B. Now, conjugate axis would somewhere be here. This length we know is, beta. So now how can we find out beta? So from here we've gotten our alpha to be 5. Now we need to find out beta. Beta is what? Our length of conjugate axis. So let us try to find it out. We know eccentricity. So first of all, since we know that alpha is always equal to 2a, so a would be equal to alpha by 2, which makes it 5 by 2. And we know that eccentricity square for an hyperbola is 1 plus b square by a square. Of course, to find out beta, we need to find out b, because beta is the length of conjugate axis. That means beta is equal to 2a. So let us find this out. Let us put all the values that we have found out here. E square becomes 4. 1 plus b square by a square is our 25 by 4. So this would become 3 times of 25 by 4 root under. This is our b. That means our beta, since 4 would be twice of 75 by 4. Now since this 4 is inside the root, when we take it root, it would become 2, and 2 and 2 would get cancelled. So beta is root 75. And we have our value of alpha as well. So what was asked to us in the question? We had to find out 3 alpha square plus 2 beta square. So from here we get 3 times of alpha square, which makes it 3 into 25, 75, plus 2 times of beta square. Beta square is 75 into 2, 150, and this makes our answer 225. So we've got the answer. Now the only a good question, I must say, because the catch here was, first of all, that they had given you an ellipse with certain center, so you had to assume x minus 1 and y minus 1 as capital X, capital Y, and then not confuse yourself with the focus that you received, which was 5, 0 and minus 5, 0. These were the focus of this ellipse that you found out. So you had to find out the focus of this ellipse. So you have to replace x by capital X by x minus 1 and capital Y by y minus 1 and find out the foci, and eccentricity you found out. Now after doing all these things, you had to remember that this hyperbola did not have its center at 0, 0. So all the formulas that you could use, which were of AE, 0 or A those wouldn't work here. So you had to find out the distance between the two foci, and we had remembered this. We had drawn a table in one of the slides where we studied that the distance between the two foci is the length of transverse axis into eccentricity. So that is alpha into E. From there we found out alpha, and once we found alpha, alpha can be written as 2a, and 2a, from there we, by using the formula of eccentricity, we could get the value of b. We got beta, and then using alpha and beta we found out what was asked to us in the question. Good question, lengthy question, a question everyone should practice at least twice for this. Let us look at this question now. This was asked in JEE Mains 2024. Here the equation of hyperbola has been provided, which is minus x square by a square plus y square by b square, which is equal to 1. Its eccentricity has been given and its length of lattice rectum has been given. So there is a point alpha comma 6 which lies on H, and if beta is the product of focal distances of the point alpha comma 6, then alpha square plus beta is equal to. Again, a very easy question. First, with the help of the equation of eccentricity and the equation of lattice rectum, you can find out what are the values of a and b, and once you've found out a and b, you can satisfy the given point in the hyperbola to get the value of alpha, and then finding the focal distance is very easy. So from there you can get beta as well, and finally the answer. So let us look at the question. Minus x square by a square plus y square by b square is equals to 1. So now by looking at this equation of hyperbola, you can understand that this, in this equation, a would be less than b, or you can say that this is a vertical hyperbola. That means the formula for eccentricity would be 1 plus a square by b square and not b square by a square. So from here e square, which is given to us to be 3 root 3, so it becomes 3 minus 1 is equals to a square by b square. So we get 2 as our a square by b square. So we've got one of the equations. Now let us find out the other with the help of lattice rectum. Lattice rectum, we know, we had studied that the formula for lattice rectum is 2b square by a. However, here in this equation, since a square has been given, which is with the minus coefficient, that means the length of lattice rectum would become 2a square by b. If you remember the hyperbola that we had studied, there the coefficient of y square used to be negative. That means the one with b used to be negative. That is why we used to use e square is equals to 1 plus b square by a square, and we used to use the length of lattice rectum to be 2b square by a. However, here you can see that minus sign is coming along with a square. That means they have reversed the entire equation of hyperbola, and so that is why we use the formula of e square to be 1 plus a square by b square, and length of lattice rectum to be 2a square by b. So they have given us length to be 4 root 3, which is 2a square by b. Let us substitute the value of a square in this equation. From here a square is basically 2b square, so 4 root 3 is equal to 2 times of 2b square by b. B and b gets cancelled, 2 and 2 gets cancelled with 4, so b is equal to root 3. And if b is equal to root 3, that means a we are getting to be root 6. So we've got our equation of hyperbola. Our equation of hyperbola is minus x square by a square is 6, plus y square by b square. What is our y square? Upon b square, which is 3, and this is equal to 1. So we've got our value of equation of hyperbola. So now we have to find out that alpha comma 6, this lies in this equation. That means s1 would be equal to 0. Let us satisfy it. Minus alpha square by 6 plus 6. Y is 6, so if I take 6 into 6, it would become 12 divided by 3 is there, because so alpha square would finally be equal to 66, and alpha is equal to root 66, of course. So we found out the value of alpha. Now let us find out the value of beta. What is beta? Beta is the product of focal distances of the point this. That means if this is our hyperbola and this is our focus, the point alpha comma 6, this distance into this distance, let's say this is p, so we have to find out p f1 into pf2, this focal distance, this is our beta. So let us find it out. We know alpha comma 6 is nothing but root 66 comma 6. Let us first find out what our foci are. F1 would be, of course, a comma e. However, in this equation, since we saw that the minus sign was with a, that means the focus would not be a comma ae comma 0. It would become be comma 0. That means we have to write this 3 times of root 3 comma 0. And what would our f2 become? It would become minus 3 root 3 comma 0. Or basically, instead of this, you can understand that if this was not to be a horizontal hyperbola, this would have been a vertical hyperbola. So from here you can understand that of course the focus f1, this would be be comma 0, 3 root 3 comma 0, and this would become minus 3 root 3 comma 0. If not in this way, you can understand this, that if this had not been a horizontal parabola, this would have been a vertical parabola, and for vertical parabola f1 would have become 0 comma 3 root 3 and 0 comma minus 3 root 3. So we, of course, you can take both the ways, whichever you feel is easier for you to solve. So now let us find out using the distance formula. Let us find out this value. So this would be equal to pf1. This would be alpha minus 3 root 3 whole square plus 6 minus 0, which makes it 6 whole square, into root under alpha minus plus 3 root 3 whole square plus 6 whole square. So let us multiply this. We would get alpha square plus 3 3 is a 9, 9 3 is a 27 minus 6 root 3 plus 36 into root under alpha square plus 27 minus plus 6 root 3 plus 36. And upon multiplying this and simplifying even further both these equations, we would get root under alpha square plus 9 into root under alpha square plus 81. And we know the value of alpha square, which has been given to us to be 66. We would get, after taking square root, beta to be 105. That means we've gotten beta as well, which is 105. Alpha, which is root 66. So what was asked to us in the question? Alpha square plus beta. That means alpha square plus beta. This would be equal to 66 plus 105. And this value is equal to 171. So we've got our answer. Again, I would say a good question. The main thing that you had to understand here is that the coefficient here of a square was negative and not b square was negative. That means the entire calculations where we had b in place of a would be interchanged, and then we would solve the questions. Now let's look at this another question. Let T and C respectively be the transverse and conjugate axis of the hyperbola. 16x square minus y square plus 64. Again, a hyperbola with some center has been provided to you, and then area of region above a parabola is given. You have to find that out below the transverse and right of the conjugate axis. Again, a good question, I would say. This involves the concepts of definite integration. So let us look at it. So first, whatever hyperbola we have been provided it with, let us convert this into a standard form. So this would become 16x square plus 64x minus y square plus 4y plus 44, or let us take 44 to the other side, equals to minus 44. So this would become 16. If I take common, this would become x square plus 4x. Let me take minus 1 common here. So this would become y1 minus 4y is equals to minus 44. Now let me add two let me add 4 in this equation so that it would turn into a perfect square. So I add 16 times of x square plus 4x plus 4. And if I'm adding 4 here, that means it is getting multiplied 16 times, that means minus 44. I have to add here as well. 16 into 4, that would become 64. Minus 1. Let me make this y square minus 4y plus 4. Again, I'm adding a plus 4 here. That means minus 4 is getting added in this equation. So minus 4 would come here as well. Now this has become a perfect square. So this becomes 16 times of x plus 2 whole square minus 1 times of y minus 2 whole square. And this value ultimately comes out to be, this is 20 minus 4, which makes it 16. If I take this thing below, this becomes x plus 2 whole square by 1 minus y minus 2 whole square by 16 is equals to 1. So we've got the equation in our standard hyperbola format. So what has they told us? They have given us a parabola. They have given us that we have to find out the area which is about the transverse and conjugate axis of this hyperbola. So what are the transverse and conjugate axis going to be for this hyperbola? Of course, we know that the transverse axis would become y minus 2 is equals to 0. I hope you all remember, for any standard hyperbola, the transverse axis used to be y is equals to 0, which is the x-axis, and conjugate used to be x equals to 0, which is our y-axis. So here y minus 2 would become our transverse axis. So y is equals to 2. This line is our transverse axis, and for conjugate, x plus 2 would be equal to 0, so x is equal to minus 2. This is our conjugate axis. Now let us draw the parabola and these transverse and conjugate axis on a graphical scale so that we know how do we need to find the area. Let us assume this is our x and y axis. So the parabola that we have been provided with is y is equals to x square minus 4. So how are we going to draw the diagram for this parabola? Let us say at x equals 0, what is the value of y? At x equals 0, the value of y is minus 4. So this is 0 comma minus 4. And what will happen when we try to find out when y is equals to 0? So we get two values of x, that is plus 2 and minus 2. So one would be, let's say here, this is 2 comma 0, and there would be another point here which is minus 2 comma 0. So this is how our parabola or our quadratic graph looks like. So we've drawn the parabola now. Now let us look at what our conjugate and transverse axis were. Our transverse axis was y is equals to 2 and our conjugate was x is equals to minus 2. So at y is equals to minus 2, this line, this is our transverse axis, and x is equal to minus 2. That means at this line, somewhere here, sorry, x equals to minus 2 is here. Let me draw this curve in a better way. So this is our x equals to minus 2. So this is our conjugate axis. This one here is our conjugate axis. So what have they told us? They have told us that we need to find out the area above the parabola, that means above this portion, and below the transverse axis, that means below the transverse axis, and right of the conjugate axis, that means let us shade the area that we need to find out. This is the area that we need to find out. So a definite integration concept would be used here. What we can do is we can integrate our parabola from, let's say, minus 2 to this point. Let us first find out what this point is and this point is. we know this point minus 2 comma 2 would be our, sorry for that, this y was 2 here, so this point would be minus 2 comma 2, and this point, the y coordinate would be 2. What would be the x coordinate be here? Since y is 2 here, so x coordinate would become root 6. So now we can integrate this entire equation based on y from minus 2 to root 6. However, we have to subtract 2 as well from that equation, because whenever we find definite integration, if you remember, definite integration basically finds out the area under the entire portion of that curve. So here we have to set a limit which is up till 2. That is why, so the area would basically be equal to, let's say we are integrating from minus 2 to root 6, and we write down this equation in the form of y. So this would become 2 minus x square minus 4 dx. I hope you are understanding how we came up to 2 minus this value, because this value integrates the entire portion, and 2 up till 2 this portion we've added a limit. So so basically this would give us the area of this portion. So let us now find it out. Now it is just a very piece of cake for us to find out the area. This would become 6 minus x square dx. So here the integration would become 6x minus x cube by 3 from minus 2 root 6. Let us put the values. We would get 6 root 6 minus root 6 whole cube by 3 minus, since minus into minus would become plus, so this would become plus 12, and here since we are subtracting, so this would become plus minus 2 whole cube by 3. Now let us try to solve this. From root 6 we are going to get 6 root 6 by 3, and after subtracting this and completing this entire equation, we would get 4 root 6 plus 28 by 3 as our answer. This was in one of the options, so that you had to take. So this question is done. Now again, I would say a very good question that should be practiced by each and every one of you. They had first of all not given a standard hyperbola. They had provided us a hyperbola with some center. So you had to find out what the transverse and conjugate axis would be. Of course, they wouldn't be the x and y axis. And then they had given you the parabola. So you had to draw the diagram, and you had to use the concepts of definite integration in this question. A very good question. Definitely all of you should practice once by yourself and then look at the solution once again. Let's move on to the next question. Let A and B respectively be the semi-transverse and semi-conjugate axis of a hyperbola whose eccentricity satisfies the equation 9e square minus 18e plus 5 is equals to 0. So first of all, we know we have a hyperbola. So E is always greater than 0. And we have been provided with an equation of E. So let us solve this equation using our solution of quadratic, which is E is equals to minus B plus minus root under B square. 18 into 18 makes it 324 minus 4 times of A into C upon 2 times of A. So what does this come out to be? 18 plus minus root under 144 by 18. So this becomes 12. So we get the value of E to be either 30 by 18 or 6 by 18. So ultimately, basically, this is nothing but 5 by 3 or 1 by 3. Sorry for that. I'll just write it here, 1 by 3. Now I hope you understand that we cannot take the value 1 by 3. Sorry, hyperbola is always greater than 1. So we cannot take this value since it is less than 1. So we have to take eccentricity to be 5 by 3. That means we found out our eccentricity E value to be 5 by 3. The focus has been given to us, and the directrix equation has also been provided to us. So we can say that x is equals to 9 by 5. If this is our directrix, then this is also equal to A by E. And we have been given our focus, which is 5, 0. So So we can say that this is also equivalent to AE comma 0. So from these two equations, let us find out what is the value of A. So A is nothing but 9E by 5, and E we found out to be 5 by 3. So 9 into 5 by 3 into 5, 5 and 5 gets cancelled. So A comes out to be 3. So we've gotten E, we've gotten A. Now let us find out what is B for our hyperbola. We know that E square is equal to 1 plus B square by A square for any hyperbola. E we have gotten to be 5 by 3, which makes it 25 by 9. 1 plus B square by A square, which is 9. If I was to take the LCM here, this would give me 9 plus B square. 9 and 9 would get cancelled. So ultimately B I would get to be 4. So I've gotten A, I've gotten B. What did I need to find out? A square minus B square. So A square minus B square, where A is equals to 3, B is equals to 4. This would become 9 minus 16 minus 7 is our answer. So this was a very easy question. Again, did not require any concepts for you to use. Just you had to find out the value of E. From E you could have found out A and B very easily, and from there you get the answer. So that was all for this chapter. I would recommend each and every one of you to go through the previous year questions that I just solved once again, because there were a few good questions, one which involved definite integration, one which involved graphical representation, and one which involved a lot of calculations as well. So going through them would be helpful for you. And these are questions that were asked in previous year JEE Mains. So you know the level of questions that are asked sometimes. Apart from that, the entire chapter of conic sections is over. We've completed parabola, ellipse, hyperbola, and we've done circle and straight lines in the previous classes as well. Now most portion of our coordinate geometry is done. So now after this we'll start studying different other topics which are probability, statistics and all. So stay tuned. Thank you.